Good evening, everyone. Uh, Thank you for joining in today. Um, am I audible? Am I visible? Is my audio video clear? Can you give me a quick thumbs up in the chat box? Lovely. All right. Yes. Great. Welcome to the webinar on accelerating embedded success. So, unleashing ready-to-use stacks and for rapid development and release. So we have two speakers for today, and I would like to personally welcome all of you who have joined in from various parts of India. Anil Kumar Sangha, thank you for joining in. Deepak Jain, Harsh Parekh, Jaisuma Jayesh, Malesh Marabonia, Boina, I hope I have pronounced it correctly, Mohit, Gil, Mayank, Pawan, Pooja, Rajesh, Shubha, Shubha Bhagatkar, right? Shubhangi, Sushant, and Venkaya P. While we are waiting for others to join in, it would be great to hear from you. Which city are you from and which organization are you representing today? I'd love to see from our guests today. Which city are you from? Which organization are you representing? Pooja says she's from Pune. Thank you, Pooja. May I have some responses from Khushbu is from Mumbai. Anil Kumar is from Unistring Tech Solution, Hyderabad. Malesh is also from Hyderabad. Venkaya is from Chennai. Right. All right. Rajesh is from Bangalore. And which organization? Mayank is from Delhi. Malesh is from Moschip, Hyderabad. Alstom, Bangalore. Deepak Jain. Rajesh is from ISIN. I hope I pronounced that correctly. Shubda Bhagatkar is from Bangalore. And which organization, Shubda? Right. So I am Vandana Mehrotra. I am co-founder Meteonic Innovations Private Limited. Yesterday we completed 17 years in business. So from a techie turn entrepreneur, our sole purpose was uh, to empower our software development community with right and powerful world-class DevSecOps solutions so that you can deliver your products on time, get the necessary work-life balance, reduce your unwanted stress related to product deliveries, and give you solutions that help you create safe, secure, and reliable software. Right. So while we were software developers, we spent sleepless nights firefighting deadlines. And one of our purpose is to make sure that our software development community does not have to go through all of this, provided you leverage world-class third-party DevSecOps solutions, right? So thank you so much for joining in today. And what we can assure is that this 1 hour or 90 minutes depends. If you have a lot of question answers, do keep aside about 90 minutes for this session. And if you have a hard stop, please do feel free to leave as and when. You will get the recording of the session after the webinar tomorrow. And do participate by asking a lot of questions, because when you participate, you learn a lot. How many of you agree that when you participate, you learn a lot? Type in the chat box why or give me a thumbs up. Do participate, ask a lot of questions. We do have people with 25 years of experience here as speakers who would be sharing their valuable insights and experiences from their other clients. Super. Thank you so much. All right. So, see, as technology is evolving, so do the demands for a quicker and more efficient solutions in embedded systems development, right? So today we are going to be diving in the world of rapid development and release, harnessing the power of ready-to-use stacks. In this session, we will explore how leveraging ready-to-use stacks can propel your project forward, ensure speed, reliability, and ultimately get you the success that you desire for yourself and your clients. See, most of us do understand the benefits of incorporating ready to use stacks in your development arsenal, right? It could be efficiency, speed, and how these stacks can significantly reduce your development cycles and time to market, right? We'll also be showing some case studies as examples where they have successfully accelerated their embedded projects using these stacks, right? The floor is open for questions, thoughts, and experiences. Anything that you would like to share, simply raise your hand and you will get the unmute permissions. If you have questions, do type in the Q&A box so that we don't miss out on your questions. Do participate if you find the insights valuable. Your words of appreciation will be very motivating for us and our speakers. So thank you so much once again for joining in. And this is a community sharing platform where we are trying to share insights and solutions that you can leverage from each other. So are you ready to receive some practical advice on selecting, customizing, and optimizing ready to use stacks for your specific needs? If yes, give me a thumbs up in the chat box. Are you ready to, who all are ready to receive some experiential insights on ready to use stacks? Super, guys. Super. Thank you so much for participating. Anirban, Shubhangi. Who else? Let me have a look at the chat box. Satish, Yushia, Venkaya. Thank you so much, guys. I really appreciate all your responses. And we will assure you that these 90 minutes or 60 minutes that you spend here, you will get we will make the most of your time. You will not regret spending your time with us. Among so much of other priorities, you decided to show up here, and it means a world to us, right? So let me introduce the speaker for today. We have two speakers today, Sandor and Gabor. Sandor will be introducing Gabor a little later. I would like to introduce Sandor, who is the head of global software engineering at Taxera. And with over a span of nearly 25 years in the embedded industry, he has taken part in architecting and implementing fault-tolerant file systems, interoperable and proprietary, flash translation layers, raw, NAND and NOR, NOR, NAND and NOR, TCP IP stacks, related security protocols, USB host and device stacks, and bootloaders for various CPUs, microcontrollers, and operating systems. So he has extensively learned about safety critical development and related processes and continue to actively help the engineering team with his expertise, right? So I'm super excited to learn from Gabor, and I'm sure you too are. Make sure you catch hold of him and extract all the valuable insights that he has to offer to you. Ask your burning questions, get your challenges addressed, and before I hand over to Sandor, I would just like to understand your challenges a little more deeper. And I'm going to be launching a quick poll, and I would appreciate your responses. So let's understand, what are your software development challenges? So the poll is on. So select your topmost challenge with software development. Are you struggling to ensure high quality software? Is that a constant struggle for you? Issues like bugs, glitches, and user dissatisfaction are recurring concerns for you? Or integrating and porting issues leading to compatibility issues resulting in delays and increased development complexity? Is that your number one challenge? Or customization requiring extensive modifications impacting development timelines and resource allocation? Is that your challenge? Or maintainability, need for regular updates and complexity of code structures often make it difficult to ensure long-term stability and ease of maintenance? Is that your number one challenge? Or ensuring adequate resources for timely project completion, right? So select your topmost, only one, your topmost challenge. Let's understand who's here, who's in the room, and how can we help you address your number one challenge. Right. Thank you so much for participating. I've got 35%, 37% response, a little 50%, 60% would help. Continue to participate in the poll, eagerly awaiting to hear all your answers. Lovely. 48% people have participated. Just need couple of more. At least we know that, right. Uh, can we have some more responses, please? Yushia, I think you are a panelist, and probably that is what the reason you are not able to vote. It's only for the attendees. Right. All right. So I'm just going to end this poll and share the results with you. So the number one in the list is integration and porting issues leading to compatibility issues. I'm quickly going to be sharing the result with you. The number two in the list is bugs and glitches and user dissatisfaction. And number three in the list is ensuring high quality software, which is a constant struggle for all of you guys, right? So, and even before there's another set of questions that I would like to ask you. So I'm going back and launching another poll, right? So just wanted to understand uh, how many of you have already bought external stacks earlier? So just it's a yes and no response. So 100% says no. All right. A few of them, okay. The numbers are changing. That's interesting. Right. Keep your answers pouring in. I would like to understand you a little better. Like, how many of you have bought external stacks earlier? All right. So we have 32% people who said yes, and 67% people who are saying no. They haven't used any external stacks, right? So in the interest of time, I am going to be quickly stopping this poll, sharing the results with you. You can have a glimpse of the result, right? So we have most people who haven't used any external stacks earlier. So ladies and gentlemen, you are in the right room. And those who are already using some external stack, I'm sure you're facing some challenges, and that is the reason you decided to show up for this session. So you will get some interesting insights on what parameters you should look at when you exploring or utilizing external stacks, and how there are better solutions that can solve your challenges, right? So I'm going to quickly share the results, take a glimpse, and then stop sharing. Lovely, right? So I do have one more poll for you guys. Okay, before I hand over to the speaker, we are just warming up, right? So um, let's see what are your challenges with third-party stack, right? Now, those of you who are using third-party stacks, right? This is for them. Those who are not using any third-party stacks, probably you're open to more insights and learnings. So those who are using third-party stacks or deciding to use third-party stacks, right? You may be processing that these could be my potential challenges, or you're already facing challenges with third-party stacks, right? So what are your current challenges with third-party stacks? It's a multiple choice answer. So are compatibility issues, limited customizations in them, dependency risks, or do you have performance concerns or security vulnerabilities are your challenges when you use third-party stack, or lack of necessary documentation and support? So this is a very active and participating audience. Thank you so much. Your results are your responses are coming in very fast. So I love that speed. I'm just waiting for a few more responses, and then we can move on and hear from the speaker for today, Sandor. Right. So can I have some more responses? Um, can I have some more responses so we can understand the majority in this room? All right. So thank you so much. The number one in the list is compatibility issues with 67 votes to it. And then we have limited customization and security vulnerabilities um, at second level on tie, and then we have dependency risk and performance concerns again on third level tie, and documentation is the last one, right? So I'm quickly sharing the results, take a glimpse, and I'm going to be stopping the screen share, right? So on that note, thank you so much. We do understand your challenges, and we are here to help you overcome some of your challenges. take some insights, valuable insights, experiential insights, and apply it in your organization right away. Over to you, Sander.
Thank you very much. I hope my screen is visible. Okay. All right. So thank you very much. It was really interesting to hear the result of these polls, and I really welcome everybody. Today, I'm going to, as Vandana explained, talk about the ready-to-use stacks and why potentially it's better to use something that exists, something that is ready-made, and something that is includes decades of experience of other engineers from another professional supplier company. But first of all, let me introduce Katja and Gabo. We three were working together on this presentation, and Katja Hakoneva is the product manager for the connectivity product at Tuxera. We are working on file systems and TCP/IP stacks and USB, and she's responsible for our cryptographic algorithms for the TCP/IP and also for the USB stack. Gabor, we are working together with Gabor for, I think, about 15 years at least. And he is also one of the core developers who contributed a lot to the software components that we ship to our customers. And myself and Vandana already introduced me, so I will skip that one. So first of all, the topic for today is to talk about the different options available when we need software to our product and need to decide how to achieve our goals. We have various possibilities because we can decide when choosing a software component to use either an open source solution to develop in-house or use a professional service. And our demanding world is getting more and more complex. Inherently, products are more complex as well, and the required software solutions too. And in a complex product, various functionalities might be needed. And it is very important to use components that integrate well with each other and with the environment. But there are other aspects also to take into account when choosing a software solution, especially if it's not developed in-house. Is it straightforward, for instance, to change CPU, to change an operating system or a tool chain? Nowadays, this can be a very interesting question. Is the design understood? Is it complex to add a new feature without damaging existing functionalities? Or are there any quality expectations regarding the product? Depending on the industry we are in, this might be key to our success. And also, from maintainability perspective, is what is the lifetime of our product? Can we guarantee the support for this whole period of time? So one of our options would be to go and choose open source solutions. And this might sound very attractive because there are many components available. It's maintained by the community, so it's actually guaranteeing maturity. In that sense, a large number of components are available, but how to make sure that all the features are. Initially, it could be that some of the features are missing from all the necessary ones that we have. Maybe only 80–90% is available, and then we need to somehow address the remaining 10 and 20. But how do we do that? Should we do that in-house? Well, there is, or should we have a contractor? But even in both cases, there might be other complications we probably can easily forget about, is like licensing issues. If our product is a competitive product on the market, we might easily miss the fact that if we add a new feature to an existing component, that component might be released to the community because depending on the licensing of that particular module, this might be required. But the other thing is that if we use an open source solution, is how can we build up the knowledge? How can we build up the understanding where and how those components are used? So how to make sure that new features will not put other existing features at stake? It often happens that, well, we engineers change something somewhere and we do not realize the consequences of that. It can damage an existing functionality. Maintained by the community is also a very attractive feature, but it's not as attractive as it sounds for the first sight, because how can we guarantee the quality? And actually, in many cases, it turns out that only few engineers are working on some modules. We have clear evidences, for instance, in our industry, that Flash-related topics are only addressed by a few very much overloaded engineers. And in such case, we have to somehow make sure that we can provide our product in time to the market. So the maturity is an interesting question as well, because maturity is, okay, the community might be testing, the community might be verifying and validating the product, but the fact that it works reliably doesn't necessarily mean that all the corner cases are addressed. It only means that only a few, the most of the issues, most of the use cases are addressed. But there could be corner cases where something doesn't work properly. A simple example I can also bring up to this is, for instance, when we 25 years ago started business, we implemented a fail-safe file system for raw NAND flash. And then over time, we had about 100 customers. And after 8-10 years, someone reported a bug, and turned out that under certain conditions, the software is not reliable. And this is something that each of us need to recognize, that the fact that something is there out on the market for 8-10 years doesn't mean it's fully reliable. So it's important to also tackle the quality perspective, the quality aspect of these products. But anyway, so when we need to decide how we acquire software, for instance, another option is to use a supplier. That supplier could be either internal, could be either external. But I mean, the risk to develop from scratch is can be considered quite high, because we need to have the required expertise level in the company. We need to understand the product. We need to understand the consequences and how it builds up. Selecting a vendor is also a complex project. So, for instance, we need to take into account how long the company is supporting the products they are selling, how many people are there in the company, how stable is the company, and do they have a solution off the shelf, or is there some customization, some adjustment is required? And if yes, is the vendor flexible enough to be able to provide this kind of customization to our solution? In many cases, we know cases from our competitors that they have something off the shelf that they can offer to their customers. And if that doesn't suit their needs, then, well, that's it. But we are flexible enough. We are happy to help our customers out with their problems. Also, another question is, can the supplier offer long-term support? Or is it easy to contact their professionals, or too much bureaucracy? So there are other aspects to take into account. Is how easy is to do the initial integration. If developed in-house, then a very specific solution could be developed matching the specific environment. The problem is that for some reason, one or more variables change over time. For example, there is a need to use a different MCU or different operating system. And to avoid that, it is essential to develop portable code that is easy to integrate to a different environment. However, a high level of expertise is required to be able to develop to different MCU, compiler, and operating system independent source code. There is a need to have a deep understanding of the developed product and its relationship with the environment. How to develop the product in a modular way such that minimal changes are required in case new hardware or operating system combination is required. What are the MCU dependencies? As an example, if we need to integrate something that is using a peripheral controller, then we need to be aware of how the cache system, subsystem works, how DMA might work, clock and power domains, how to configure GPIOs. So this might get quite complex in certain situations. But also from operating system perspective, what kind of resources, services are offered by the different operating systems? How would those integrate with the resources used by our software components? There are various different operating systems available on the market. So there are, with the simplest ones like FreeRTOS, it might become straightforward. But if we want to move to higher quality in certain environments, there is a need to guarantee freedom from interference. And in that case, our software should be capable of operating in memory and time-separated processes. But now, why to do portable code? So, I mean, 5-10 years ago, probably this wasn't such a critical topic, but nowadays there are supply chain issues. And as such, our products are more vulnerable. It could be that we are not going to be able to buy the same processor in 5 years' time. And to be able to still supply the same product to the market, we need to be able to migrate to a different MCU. And if the software is developed in a modular way, it's developed in a portable manner, then this pain, this burden on the engineers is going to be minimal. The natural consequence of moving to a different MCU, especially if it's from a different vendor, is that most likely the compiler will have to change as well. And that code has to be portable. I mean, it should not include, let's say, compiler-specific pragmas, compiler-specific keywords. It should straight away compile on any other different environment. But needless to say, there are other aspects as well. So for instance, if we have a well-optimized memory copy function as an example, then it's really good to have a code implemented in a way that it's straightforward to move to a different memory copy implementation. And from the RTOS perspective, I already described that the portable code might be interesting from the aspect that it could be that we need to migrate to a different operating system. But also there are other aspects, like we need to guarantee a certain memory footprint. We want to, let's say, we want to integrate a file system or a TCP/IP solution. It is essential that depending on what environment we choose, we can meet the memory footprint and the performance requirements. Of course, there are limitations because naturally we cannot achieve the maximum performance with minimum amount of RAM. But also the other thing we learned over the span of 25 years is that, I mean, when someone asks the question of how much RAM is enough, that the answer can be really different. For some customers, a lot of RAM is 32 kilobytes. From some others, 1 gigabyte is a lot. And we have to be able to integrate our software to different solutions. Customization is also a very important aspect. So if the solution is not ready to use, then naturally we have to do something about it. If it's not ready to use and it does not offer all the features that are required by our environment, then we either make a compromise, accepting the missing features. We can find alternate solutions, or customization is required. And for open source solution, it needs to be done in-house or by outsourcing the work, or if a supplier is offering the whole solution, they need to help. The advantage of using an external supplier is that they have, if they are mature enough and they have deep expertise in the products they are selling, but hopefully they are. So the advantage of using an external supplier is that they have good understanding of the market, good understanding of the different solutions, and often enabling them to help in finding the best solution. And so in many cases, we have discussions with our customers, and by understanding their environment, by understanding their use case, it often turns out that what they were really looking for, what they were preferring to, what solution they were preferring does not necessarily is the best to their environment. And maybe it's not going to guarantee the required lifetime. Maybe it's not going to perform as well as expected. And then having an external supplier with all the expertise, all the knowledge, we can give hints, we can give help, we can potentially combine with other products to achieve the goals. There are quality aspects as well. So software quality is in our more and more demanding world is becoming a key aspect. So we have different options. We can have basic quality, and that covering static analysis like MISRA, for example. And MISRA stands for Motor Industry Software Reliability Association. So that's quite interesting. But we can have the need to address all the vulnerability issues, cyclomatic complexity, dynamic analysis would be required, standard branch MCDC coverage. And also cybersecurity and vulnerability aspects can be an interesting topic for in nowadays. For this, there is a strong collaboration required between the customer and between the supplier. The supplier and the customer needs to identify together what the potential vulnerabilities are and what the countermeasures could be, how to address this. If we sell, for instance, products to the US market with cryptographic algorithms inside, then most likely FIPS 140.3 would be required. And having a supplier knowing all these details, all these tricks, then that would help a lot. So, on the other hand, functional safety could be an interesting aspect as well. So, there are different standards available: IEC 61508, ISO 26262, which is for automotive. The IEC 61508 is for the industrial environment. ISO 62304 is for the medical. The 0178 is for space, for avionics. And there might be requirement to follow the full V model and addressing different safety cases depending on the different industrial functional safety. For full V model, it's a very complex project. Usually it's about 6-8 times more to implement a stack that complies this functional safety standard than developing something from scratch. A full V model involves having the high-level requirements, functional level requirements, architecture design, detail design, the implementation, fulfilling all the static dynamic analysis criteria, verification, validation, full test specification, and last but not least, full traceability. This is a quite complex piece of work and requires huge level of expertise, a lot of engineering years collecting, gathering the expertise required to be able to work according to this. So, from a maintainability perspective, the expertise required to ensure long-term maintenance of a product is frequently underrated. Sometimes if we have software in-house and we have expert engineers as well working in our company, then we tend to say that, oh yes, we have an expert engineer, he or she, they are able to fix all the potential issues. But if, for example, they do not have the required level of expertise, if they are not professional in the target area where the product is, then it may become a nightmare because even if the bug could be fixed, maybe there are other 2 bugs introduced. So there is a high risk here that needs to be considered. So as a summary, software development is a complex procedure. There is a need to pay attention to a lot of details about integration, portability, customization, quality, maintainability. We need to decide whether we are going to use an open source solution or something that we develop from scratch, or we take use of an external supplier. But professional suppliers are also quite useful because if there is a time pressure, then there is no time to build up the expertise. So we at Tuxera, we have decades of experience in developing software for storing and transferring data reliably, quickly, and securely on deeply embedded and embedded environments, from smallest microcontrollers having a couple of kilobytes of RAM available to the largest supercomputers with several gigabytes of RAM. We develop platform-independent code. Effectively, that means that we are able to integrate in any microcontroller, any MCU, or any CPU. It is compiler and operating system independent completely. I mean, with real-time operating systems and operating systems, we have software running on FreeRTOS, we have software running on on Safe Atos, on Micro COS, on CMX. We can run our software on Linux, on VxWorks, on QNX, or popular platforms. And our solutions are very modular. So this allows integration of only the required components, putting the minimum burden on the environment. Any kind of combination can be put together. That, of course, that makes sense. We can also bring the required level of quality. We have knowledge in-house about the cybersecurity, the vulnerability issues. We have knowledge in-house about the functional safety and many other things. And we are quite flexible in offering and accommodating the best solution to your product. So this diagram gives an overview about the products that we offer to our customers. As you can see, on the left side, you can see the OS abstraction layer, which gives you the ability to integrate to any other operating system. So the way it's structured is that all the modules, none of the modules are going to change except for the OS abstraction, operating system abstraction layer, if you need to integrate to a different environment. So once you have all the components integrated to your project, there is only a need to change a few files and it will instantly work out of the box on a different operating system without any additional burden. With the file systems, as mentioned, we have the ability to work on many different environments. We can work on Linux, we can work on FreeRTOS, and all others. We have fault-tolerant, interoperable, and proprietary file systems with block device interface, or we can use them directly on NAND or NOR flashes. The networking stack is also part of our offering. This is something that we have been developing for the past 16, 17 years. And we developed something that conforms to the 21st century quality requirements and also performs very fast compared to other solutions, depending on the environment, because we can achieve zero-copy solution. Over the past 15 years, we have developed many different applications, many different security components. We have the MACsec for layer 2, we have IPsec for layer 3, we have layer 4 for TLS. We have many applications, dozens of different applications, DHCP server, client, DNS, HTTP, FTP, TFTP, MQTT client, and we have our own version of the server message block running on Linux. And the real advantage of this server message block component compared to other solutions is that we are able to handle much more shares, much more clients at the same time compared to our competition with much lower CPU load. We also have our USB components, and these USB components, similar to the networking stack and the file system, have been used on hundreds of different microcontrollers, have been used with dozens of different operating systems, dozens of different compilers. So it's proven that it integrates well, and it's straightforward to migrate from one solution to the other. With USB, we have the host and device available. We have general class drivers like HID audio. We have the networking ones, CDC, ECM, EEM, NCM, and RNDs. And we have storage ones as well, like storage and MTP. And we have our own implementation of the cryptographic components like AES, CHA-24, TLS 1.3 as an example, DSS, the elliptic curves, and D5, RSA, the SHA, SHA-1, SHA-2, SHA-3, the triple DES is available. And we are currently working hard on achieving the cryptographic algorithm validation compliance, which is the entry room to achieve the FIPS long term. But at least in the end, it's verified with NIST's US-Canadian organization test server that our cryptographic algorithms are working as expected. And we have expertise in bootloaders as well. And last but not least, Gabor is going to show you a demo where we are going to put together an environment where an HTTP server will be connected to a PC. And how he is going to do this is by using an STM32 development board which has an Ethernet controller. And on top of that, he's going to integrate the Tuxera TCP/IP stacks Ethernet driver, then add the next layer for the IP layer, then the TCP layer, and then he will add the HTTP server on top. On the other side, for the HTTP server, we need the ability to be able to share an HTML file with the PC, but where to get the HTML files from? Well, that could be achieved with a file system. So we have an SD controller. We have the SD controller driver that we have implemented ourselves. And on top of that, there is the FAT file system. Now, the only thing we need to do is to connect the HTTP server with the FAT file system and then connect an SD card with the SD slot of the STM board. And now we suddenly are able to share HTML files via the HTTP server to the external world. So what needs to happen now is that we will connect an external a notebook via Ethernet to our board. And then that shows how well, how modular our products are and how easy it is to integrate it. So with which I would like to thank you very much, and I hand over to Gabor.
Thank you. Thank you for the introduction. And I just started sharing screen. I hope it is visible.
Yes,
okay.
it's visible.
Thank you. Okay, so yeah, like Shandor mentioned, I'm going to demonstrate how to integrate Tuxera software into any customer project. I won't do that in that detail that I wanted, that I'd like to, because I was told I have roughly 10 minutes to do this demonstration, and it would be impossible to show all the aspects of the integration and porting, but I try to make it as understandable and interesting as possible. Now, what you can see on my screen on the left-hand side is an actual package delivery from Tuxera. So as a Tuxera customer, if you order some software packages, then you will either get a full working demo, which is another thing, but now I'd like to focus on this package type delivery, where you get the like Shandor said, RTOS independent, MCU independent, environment independent middleware software packages. Here we have this in form of lots of these zip files. Well, in this example, we have lots of packages. So in this example, we have the FAT file system, many IP stack related packages. We have the media driver belonging to the file system so that it can communicate to the actual storage medium. We have other network driver based packages that will be used by the IP stack. And we have many other things. In this example, we even have USB device, for instance. Now, in order to be able to show you the basics of and the ease of the integration of these packages, let me just quickly walk into one of these packages. So let's take this FAT package, which is the base package for the deeply embedded FAT file system, and which also has a safe a power-fair safety extension, by the way, in other package. So if we go into this package, and we could do this with any of these, the basic file structure, folder structure is the same all the packages. So if we go into this package, we always have the same top level Tuxera directory, which then can be placed into the customer project, into the actual embedded project. Now, if we just get into this directory, we have these folders. In the documentation folder, we always have the actual up-to-date documentation belonging to the product, which is, of course, very useful when doing the integration. If I just quickly open the documentation for the FAT file system, then we can see that it includes everything that needs to be known about the integration, the API, the configuration. Like, for instance, I'm going to the configuration options, and I have all the compile time configuration options defined and described here that I will have to use when doing the integration. Now, I have the history file, which is also very useful because that contains all the modifications that happened with the actual module during the time. And from this, you can learn what has changed, what was the reason for the change. And based on that, you can decide whether to integrate it or not, for instance. The info folder is more like for internal usage, but more important is the source folder. So inside the source folder, I have the actual source files belonging to the software module. We provide source code delivery, so you can see actual source code here, and we always have the very same structure. We have an API folder which contains the API header files. These will be the header files that your application will need to include in the end. And the things defined in these files are the things that your application will use on the field. Well, yeah, for instance, let's have a look at the API functions. We have the let's go a bit down. We have, for instance, this is a very common thing, the init volume function. It will be found in the documentation. If you look at it, you will learn how to use it. And using this, you will be able to initialize your volume using the SD card, for instance, but you could use any other storage medium with the file system. Then we have the configuration folder, which is in the packages named config template. This has the idea behind that is that like this, whenever you do a package update, you won't overwrite your existing configuration, because in your project this will be named config, and then you have the actual source code, and then you have a version which defines the actual software version. Now, let's have a look at the big thing why we are here, the actual integration. So yeah, what to do first? I have prepared a base project. I guess maybe many of you are familiar with this project structure, because this was generated with the STM32 CubeMX project generator software, which is freely available from STMicro, and many STM32 users are using this to generate base projects. So this is nothing miraculous. This is a really basic project. Now in this project we have many folders all generated, and one of those is the middlewares, which has this third party and which already has FreeRTOS, because I chose FreeRTOS as my RTOS in this base project. This is the only middleware right now in this very minimal project. I think this project maybe blinks some LEDs or I don't know, prints hello world or something like that. So this is really something initializing the board and doing something demo. Now, the first step for me to do anything with starting the integration is to put my Tuxera modules into this base project. Now, I could put it anywhere in this project, but I chose this middleware third party because from the project's perspective and from your perspective, we are also a third party middleware provider, just like FreeRTOS. So to make it simpler, I've made a smaller set of packages which only contains the safe fetch related packages. And I'm just going to show you quickly the really first steps that are needed to add the fat file system itself to the project. So I'm just selecting all these components and doing nothing but unpacking them to the same level where FreeRTOS was. So right now, at least on the file level, I have two kinds of middlewares, FreeRTOS and the Tuxera middleware things in the project. If I have a look at Tuxera, we can see that all the documents are in the doc folder from all these packages on the left-hand side. I can use them, I can browse them, I can read them. All the histories are here, and all the source files are here from all these packages on the left-hand side. Now, this is all very well documented in our first step guides or quick start documents. But the first thing to do is I rename the config template to config. And we have this PSP template. I will explain this later, but PSP is for platform support package. This is the part that is connecting the RTOS and environment and MCU independent packages to the actual MCU architecture and environment. Now, I'm just doing one more tiny copy to have everything in place in my project. And now I can even get rid of the PSP templates. Those were here for me to help. I use them. It's okay. And what we see now is how a FAT project actually would look like in the end project and embedded project. Well, not fully, because we would need some additional components like media driver, but that doesn't really matter for now. Now, if I'm changing to the actual IR project that has this that was created here, also auto-generated by the STM32 code generator, then we can see this base project. There's application drivers all generated by the ST stuff, and we have FreeRTOS here. Now, because I decided to add my Tuxera, I'd like to only add the FAT file system. Let's add another sub-component FAT or subfolder FAT and try to add the files that I just copied from my Tuxera delivery. It is here. These are the FAT source files. I'm just adding those. And at that point, so I literally did nothing, just copied a couple files into the project. I try to compile this. And it built without any error. So I literally did nothing, just copied everything into the project. and added the things to my IR project, and I already have something I can build. I already have something I can play with, I can configure, I can even start porting. I think that's a huge advantage of how Tuxera products are built, because I don't know how you are with that, but me as a developer, I always like to start with existing examples, existing reference codes, and start doing things, building things, and playing around with code rather than going through hundreds of pages of documentation. And because of how these packages are built up, I think it's really easily doable that way. But now, since I don't have much time, I created another project that has the whole integration done. So I switched to that project. As you can see, the project structure is the same, but under Tuxera, I have all other products. I have the FAT, just like in the previous example. But besides that, I have the media driver for that. I have the SD driver for that, so that my embedded application will be able to create and use files on an SD card. And I have all the PSP, the platform support package portings available already. Now, just a few things about what I needed to change with all these products integrated here. Like we have this configuration, and let's have a look again at the config FAT. So the FAT configuration, here are all those config parameters I quickly showed you in the FAT file systems documentation. Let's find something that is quite obvious what it means. For instance, long file name. Quite obvious. If this is enabled, then long file names are supported in the FAT file system. If it is not, then they are not supported, but the file system will consume a lot less RAM, or it at least will need less stack available, for instance. So because this is deeply embedded, these things must be considered. So I have configured all these things in the configuration, and I've done the required portings in PSP. Let's have a quick look at something in PSP, because Shando mentioned the memcopy, for instance. This is a good example. So whatever is used and is memcopy related in Tuxera code, that is accessed by calling the PSP memcopy macro, rather than calling the standard memcopy macro. And using this PSP port files, you could even create your own memcopy function, or use any memcopy, or do anything, and map it to our PSP memcopy, so that will be used by our things. And very importantly, we have the OAI layer, which stands for OS abstraction layer. That was also mentioned by Shando, that this is the layer that connects the Tuxera modules to the RTOS or to a non-RTOS environment, which is also possible. This right now is a FreeRTOS project, so I have the RTOS, I have the FreeRTOS specific OAL porting here that came with the delivery, so it can be used as is. I don't have to do anything to connect my modules to the RTOS, which is FreeRTOS in this case. It will just work out of the box. And besides that, I have the my simple demo application. I have my demo.c. Like I said, I'm using all these API files that are in the API directory, and I'm using those as described in the documentation. I'm initializing things and doing some really simple demos. Now let's, okay, so the hardware I'm using is this one, really popular, simple STM32H7 Nucleo board with an Ethernet connector, and that Ethernet connector is connected to my PC's network card, and there's an SD card connected to the board. And on that SD card, I have an HTML file and 2 images. And what I'd like to see is that this board is also running an HTTP server on top of the IP stack, and I want to see those that HTML file and those images on my PC. Now I connect the cable. As we can see, I already have an IP address. The interface is configured. Let's try pinging my board. That works. So these ping replies are already returned by my embedded IP stack. And here I have the demo page that is already loaded from that IP address, which is my board's IP address. And as simple as this, I just copied everything into my base project. I added the very standard initialization and minimal demo things I ported. I needed minimal porting and do the configuration. And I already have a functionality like this, which is quite complex already. Yeah, so this is what I wanted to show you. I hope it was understandable.
Thank you for those details, Gabor and Sandor. And if you have questions, just simply raise your hand or type your questions in the chat box. If participants have any questions, please do. I'm going to give you unmute permissions. Simply unmute yourself and ask questions. So is this what you were looking for? Have we addressed the reasons why you signed up for this webinar? Do let us know. And if you have any questions, simply raise your hand. And I think all of you have been given unmute permissions. You can simply unmute yourself and speak. Can we have some responses? Is this what you were looking for? Did the session make some sense to you? Okay, am I audible? Am I visible? Super.
Yes.
Okay. Kindly change your chat settings to everyone. And Ankur, Dave, Harsh, I think Shubda raised her hand, but I can't see you anymore. Super, Venkaya, thank you so much for your response. Yes, it is clear. All right, so do you have any questions? Did the session address some of your challenges? Is it what you were looking for? Can I have some responses from the participants? Right. Yes. Okay, thank you so much. Am I seeing the same chat, or am I getting some new responses on the chat? All right, so I do no questions. Okay, so then we did a fantastic job. We'll assume that all your doubts have been cleared. All right, so we do have a question. Is
Yes.
adaptive AutoSAR based solution supported? Super, thank you.
So
Do
we can
change
take-
your chat settings to everyone, because I think only the host and panelists are receiving your comments. So we do have a question from Malesh Maraboy. So from Raja Shekaraya M. Is adaptive AutoSAR based solution supported? Sandor, Gabor?
Can you hear me?
Yes.
Okay. So with adaptive AutoSAR, we have integrated our solutions to the AutoSAR environments in many cases. I mean, we are supporting the OSEC operating system as an example, and that has two different flavors, as I understand. One is where it has to be executed in predefined amount of time, and do we have the solutions for being able to integrate our components into such an environment. And the other one, as I understand, is also when there is some kind of a memory separation. And in that sense, these are all known problems to us. Does that answer your question? Maybe.
All right, he
Okay,
says yes,
thank
thank
you.
you.
He replied.
I do have
yes.
some more couple of polls more. One was about what are the typical change within your project life cycle from development via different product variants, versions to end of life, right? So it would be good if you can share answers to this question. Thank you so much. I've started receiving the responses. Right, we'll wait for some decent number of participation and then quickly end this poll as well. Yep. Can I have some more responses? I just need to cross 50% at least, so we know that what we are speaking is applicable to the folks present today. Yeah, some more. Lovely, got it. Thank you so much. So I'm going to be ending the poll and sharing the results with you. I think 56% goes to compiler and development environment, 31% to RTOS, and 25% to MCU and PCB design, right? So thank you so much for your participation once again. And I think I have one more poll. It was about the need for ISO 26262 or IEC 61508. So the question is, do you see a need for ISO 26262, IEC 61508, ISO 62304, or DO 178 certifiable software? So, yep, unanimously the answer is coming as yes. So, okay, the numbers have changed. 93% says yes. All right, okay, the number has changed again. 88% says yes. Okay, numbers have changed again. So I'll wait for you to answer the poll. All right, final call, 1 2 3. All right, I'm going to end the poll, and 75% have said yes and 15% have said it depends. So those of you who have shared it depends, we'd love to hear your answer, right? When you say depends on what, right? If you would like to elaborate your answer, you have the unmute permissions. Simply unmute your voice and share your insights or anything, your thoughts, your opinions, your experiences in this. I'll give you, all right. We have Anil Kumar who has raised his hand. Anil, please go ahead and you can let me know if you are able to unmute yourself. Right. Are you able to unmute yourself, Anil? Anil Kumar Sangha? If not, I am not sure if you raised your hand now or you had raised it earlier. All right. So if you're still around and if you have something to share with us, please unmute yourself. Otherwise, we'll quickly have a small poll. It's not a poll, it's a quiz here. I'm going to be launching a quiz. And those of you who answer all the correct questions, we will have Zoom creating a file for us. Do expect a goodie bag from us. So I'm going to be launching, there is a set of 3 questions. I've launched the quiz for you. The first question is, which industry is ISO 62304 for? While you are answering these questions, I would like to thank Sandor, Gabor, Katya, Eugene from Tuxera team, and my team at Meteonic, who worked for over 3 to 4 weeks to facilitate this webinar today. And I really appreciate their dedication and support to make this happen. And I would also like to thank all the attendees who took out time today to hear what we had to share. And we look forward to serving you in future with powerful insights. And if you would require specific and exclusive discussions with your team, do let us know. We are more than happy to serve you. Share a link in the chat box, fill the details, and you will get priority. Thanks, everyone. So the quiz questions, the second question was, which OSI layer MaxSec is operating at? And the third one was, what does Mishra stand for? So I think I've received responses from most of you. So the correct answer for the first one is, can I have some responses in the chat box? What industry is ISO 62304 for? Can I have some responses in the chat box? Because most of you have answered medical. Thank you, Ravi. That was supersonic speed. Dave Mandal, Mayank, thank you so much. Right. So let's have the answer to the second one. Which OSI layer MaxSec is operating at? Mayank says level 2. Ravi says layer 1. Well, it is layer 2. Layer 2. Layer 2. Layer 2 is the right answer. All right. The third one, what does MISRA stand for? Is it Motor Industry Software Reliability Association or Machine Industry Software Reliability Association? Can I have some responses? Dave Mandal says Motor Industry Safety or Software? Software. Lovely. All right, guys. So thank you for all your responses and thank you for staying with us for so long. And I hope this session made sense to you. If it did, give us some emojis, thumbs up, share your love with us quickly. So we know that the right audience is in the room and we have served you with what you needed today. Thank you. Anirban gave a thumbs up, right? Can we have some more? Super. Albert gave thumbs up. Malesh gives a thumbs up. Thank you so much, guys. Thank you. Love all your responses. And thanks to Team Tuxera. Anybody wants to say anything, share anything? Team Tuxera, do you want to say anything?
The only thing I would like to say is that thank you for the all attendees to listen to us today. I also hope it was quite useful. And I would also like to thank you very much, Vandana, that you have organized and the whole Meteonic team this webinar. It was really, really good. Thank you very much.
Thank you so much. One second. All right. Sorry, I'm on 2 systems because I'm having little trouble with the speaker of my laptop. I hope I did not cause a lot of disturbance and a lot of noise. Thank you so much for to all of you. We look forward to seeing you again in yet another knowledge sharing and empowering webinar in helping you address your DevSecOps related challenges. Till then, keep growing, keep evolving. Bye for now.
Thank you. Thank you, everyone. Bye-bye.
Thank you. Bye-bye.
Thanks
Goodbye.
all.